Analysis of data. Statistical analysis, or statistics, is concerned with the development and application of methods and techniques for organizing and analyzing data, usually quantitative, so that the reliability of conclusions based on the data may be evaluated objectively in terms of probability. There are two or more areas or types of statistics: theoretical and applied. Role of statistics. The basic purpose of statistical analysis is to summarize observations or data in such a manner that they provide answers to the hypotheses or research questions. The field of statistics involves methods for describing and analyzing data and for making decisions or inferences about phenomena represented by the data. Cautions in using statistics. The statistical analysis cannot do the interpretation. The researcher should be aware of other concerns in using statistics. Control the research setting. The less is the need, in general, for certain statistical techniques. The analysis process should be planned well in advance in order to anticipate problems that may be encountered. Steps involved in statistical analysis. The set of categories or values for any one variable should be derived from a single classificatory principle, which is determined by the research question or hypothesis being investigated. Second, each set of categories should be exhaustive. Third, the categories within each set should be mutually exclusive. Coding the data. Once the categories have been established and data assigned to them, it is necessary to convert the new data or responses to numerical codes so that they can be tabulated or tallied. These codes are in turn assigned to specified locations in data files, particularly if computer data analysis is planned. Analyzing the data. Descriptive statistics. Descriptive statistics, which have been the predominant type of data analysis employed by researchers in library and information science. There are at least 6 basic functions that they can perform. 1. At the most basic level, the statistical analysis can indicate how many persons, objects, scores, or whatever achieved each value or fell into each category for every variable that was measured. 2. When it may be difficult to grasp the overall meaning of frequency distribution tables, pictorial representations can be used to portray a variety of characteristics of the cases or individuals with respect to the variable or variables measured. 3. Descriptive statistics are capable of characterizing what is typical in a group of cases. Such statistics, referred to as measures of central tendency, commonly include the mean, the median, and the mode. 4. Descriptive statistics can indicate how widely cases in a group vary. 5. Descriptive statistics can measure the relationship between or among the different variables in the data. The sixth basic function that descriptive statistics can perform is to describe the difference between two or more groups of individuals. Analyzing the data. Inferential statistics. Inferential statistics can perform certain more sophisticated functions. They are most commonly used to predict or estimate population parameters or characteristics based on random sample statistics, and to test hypotheses using tests of statistical significance to determine if observed differences between groups or variables are real or merely due to chance. Inferential statistics are based on an assumption of random sampling and on probability theory, and the researcher should have a good understanding of the basic concepts. Inferential statistics themselves are of two basic types: parametric statistics or tests and the non-parametric statistics or tests. Parametric statistics. Most important, parametric statistics require the assumption of a normal population or distribution. When the data of a normal distribution are plotted on a graph, they should produce a curve that is symmetrical and unimodal. Its mean, median, and mode should all coincide. And there should be a constant area, or proportion of cases, between the mean and an ordinate, which is a given distance in terms of standard deviations. Some examples of frequently used parametric tests include the following: z-test, student's t-test, difference of means, analysis of variance, post hoc tests, reliability coefficient, persons, product, moment correlation, coefficient, and regression. Non-parametric statistics. They do not require the assumption of a normal population and therefore are often used with smaller samples. As they involve weaker assumptions, they are less powerful than the parametric tests and require larger samples in order to yield the same level of significance. 5 common examples are as follows: chi-square tests, Mann-Whitney U test, Wilcoxon sign test, Spearman rank order correlation or Spearman's P, Skoskal-Wallace test, selecting the appropriate statistical test. Selection of appropriate statistical method depends on the following 3 things: aim and objective of the study, type and distribution of the data used, and nature of the observations. Cautions in testing the hypothesis. There is a growing interest in meta-analysis, which generally refers to a set of statistical procedures used to summarize and integrate many studies that focused on the same issue. It represents a numerical rather than narrative method of relating findings and is considered to be more objective, reliable, and rigorous than the latter. Lopez-Lee analyzes meta-analytic articles written by policymakers and social scientists. He concludes that meta-analysis can either blur the distinctions between the studies or provide misleading conclusions. Weighted data, missing data, small sample sizes, complex sample designs, and capitalization on chance in fitting a statistical model are sources of potential problems in data analysis. Statistical analysis software. Numerical data can be submitted into statistical software programs on personal computers or PCs and servers. As computing power increases, statistics programs are continually being updated. BMDP software. It can be used for a variety of statistical analysis and is not limited to medical research. SAS, originally Statistical Analysis System. It tends to be used most frequently by researchers and IT staff in technical fields, but the system can in fact be used for virtually all kinds of data. SAS can be operated through a graphical interface or via application programming interfaces. Manytab is a relatively easy-to-use statistical and graphical analysis software package which allows for extensive use of alphabetical data. MicroCase, another statistical analysis and data management system, was developed for social science researchers and is available for personal computers. The SPSS Systems is a comprehensive, versatile, and relatively easy-to-use computer program for statistical analysis, report writing, tabulation, and general-purpose data management. It provides a suite for modules containing numerous statistical procedures, from simple tables to multivariate analysis. SysStat is another comprehensive statistics, graphics, and data management software package. SYSTAT, as is true of some of the other packages developed for the PC, provides a statistical graphics capabilities comparable to those available with mainframe program. A free student version is available.